welcome back to the shop. So, haven't been around for a bit. Been dealing with the blood clot thing. Everything is pretty much figured out. No other issues found, which is good. The heart and everything, all the good stuff in the system is doing what it should be doing. We just don't know why we had that random blood clot. But pretty much back to 100%. Plus, lately it's been like months of 90 plus degree temperatures. So I've been running around like nuts at work. And when I do have time at home, I've actually been reorganizing the shop here and doing some infrastructure upgrades, and we'll get into that later. What I need to do right now is make a project for work. This is something that is very weird, and I haven't come across in 21 years, and I don't know why it's all of a sudden an issue now, but it's only an issue in a certain area. And we'll go, why don't we come over to the bench and I'll show you exactly what I'm talking about. So, we have a client that has multiple locations. He's a franchisee, which is totally fine. I got a call from him last week saying that he's getting written up. I don't know if it's by the actual town health department or the actual inspector, corporate inspector for his franchise operation, but he's getting dinged on his ice machines pretty hard, and this is something I've never had come across as an issue. And the ice machines that he has, in particular, are Hoshizaki ice machines. And we do the PMs on them, so we clean them every 3 months, pretty much. They get a complete douching. Now, the problem arises is physically in the bin. In the bin that holds the ice is a white plastic bin deflector. And that bin deflector is held in by plastic screws screwed into the top and the sides. You kind of get an idea of it by this picture here. You can, if you look on the side, you see the little black knobs. Those are the screws, and then that big white thing is the bin deflector, if you look at this picture here. Okay, so the problem arises is Hoshizaki makes that piece removable, unlike some other manufacturers, so that you can actually clean behind it. Okay, now the problem is those screws that are screwed in the top are these ones here, right? Plastic coated screws. And the ones that screw in the side are these, and you just fit through a hole and they screw into the side of the bin. Where they screw into the side of the bin, all it is a brass grommet that's pressed into plastic, because it's an insulated bin. So the bin is about 1.5 inches to 2 inches wide, and in the between is foam. And they have those little, melt in or push in brass grommets that this will thread into. Well, from that taking a beating over time, those grommets either break or they fall into the bin, and these screws kind of tend to fall out. Now, what we do is we take a stainless steel screw and a stainless steel washer and screw them into the plastic and into the bin, and this has enough grip to hold everything. Well, this inspector doesn't want to see screws. This is actually the screw that I physically took out of there, and this has been in there for over a year. And I tried to explain that, the screws and washers that we use are stainless steel. They're not going to rust, and even if it does build up anything, we clean these ice machines every 3 weeks. Well, they didn't want to hear it. They want the original screws into place. So the problem arises is you cannot screw this back into the hole because that little brass grommet is gone. So your only option is to figure out some way to get threads to hold in the plastic with some sort of contraption or some sort of expensive thing, or my idea is to remake the damn things. So that's exactly what we're gonna do. So we're gonna make a bunch of these. So it's a copy of this, but instead of having the machine screw on the end, this has basically the stainless steel screw with the head cut off and screwed into there. So now we can screw these directly into the plastic, and this gives enough grip to hold, and it's not going to fall out. So I have to make a bunch of these. So let's go and do it. Okay, so we're getting ready to make a copy of this. So I got it down to as few operations as I can. So I think it's 7 that I counted. So first we're going to face. Then we're going to turn the outside, the larger diameter, turn the smaller diameter. We're going to drill. We're going to insert the screw. Then we're going to part and chamfer. And so, including cutting the screw, 7 operations. So that's not too bad. And this is all plastic, so we can actually basically take everything is one cut. So, first thing we're going to do is face. And I've set my dial indicator on my carriage for our smaller diameter cut. So first we got to take off 75 thousandths, 75. Now we got to take off 750 thousandths, and we can do that in one shot. So there's 1, 2. I'm sorry, 325 thousandths. 325 thousandths. We got to do that for a length of 750 thousandths. Three, 4, 5, 6, 750 thousandths. Lock down the carriage, face out. And where you're going to drill, not bother with center drilling, no need. Now, so here is my screw, and what we're going to do is we are going to cut it off about 1/4 inch to 3/8 of an inch from the end. We're going to cut that off. So we're left with this, and we're going to take our drill chuck here, and we're going to, you know, eyeball about halfway, which is going to be somewhere in that neighborhood. Put it in a drill chuck, and just by hand, I'm going to manually screw that in. And we're pretty good there. And now we are going to take our parting tool and use our original screw for reference here. Up there, lock it down. And then I'm just using a threading tool as a chamfer tool. And there it is, and what we can do is just snag a utility knife and just carefully snap that sucker off. Now we can go over to the mill. Okay, so now here's the good thing about ER collet chucks. This is a 3/8 collet chuck. This is 350 thousandths, and this can squish down enough to be able to hold this. So what we're going to do, this is already lined up and already set up. Get a 2-flute cutter in here, and basically I just measured off of the old one, determined that I got to take about 50 thousandths off, nice round number. So I touched off once and went down 50 thousandths. So this is 100% set, and it's set on center line. And then all I have to do is just rotate this. So you turn the mill on. Alright, and there it is there. So now we want to get the machining marks out of it. The only reason why I want to do that, I want to make it as smooth as possible so that way it doesn't build up any gunk. And I'll show you a very easy way to do that with Delrin plastic. Okay, so this is what we're left with here. And this is just some 400 grit wet dry sandpaper. And a few swipes of this will take the machining marks off, but you see I got scratches. So we're going to just do all the sides here. Doesn't have to be perfect. And then the top here. Again, doesn't have to be perfect, but now get a torch lighter or one of those little mini torches, light her up, and then just, without melting it, just heat it up. Just like that. And you can see it turns gloss and gets rid of all the danglies that you had on there. Obviously, you don't want to catch it on fire, but just a little touch here and there, And then on this side, we'll give you a decent gloss finish. It's not perfect, but it'll do. If you want to go crazy, I mean, you can polish it up. What I'm just trying to do is just not get any grooves in there for kind of schmutz to grab onto. So, I mean, if you wanted it, get that piece a little bit better. You can go with some finer sandpaper if you want, but that's good enough for me. And what we gotta do, now I just gotta make a bunch more of them.